two canaries in the coal mine. First one is in the Arctic. This, of course, is the Arctic Ocean, the floating ice cap, Greenland on its side there. I say canary in the coal mine because the Arctic is one of the two regions of the world that is experiencing faster impacts from global warming. This is the largest ice shelf in the Arctic, the Ward Hunt ice shelf. It just cracked in half 3 years ago. The scientists were astonished. Starting in 1970, there was a precipitous drop-off in the amount and extent and thickness of the Arctic ice cap. It has diminished by 40% in 40 years. And there are now two major studies showing that within the next 50 to 70 years, in summertime, it will be completely gone. Now, you might say, why is that a problem? And how could the Arctic ice cap actually melt so quickly? When the sun's rays hit the ice, more than 90% of it bounces off right back into space, like a mirror. But when it hits the open ocean, more than 90% of it is absorbed. And so, as the surrounding water gets warmer, it speeds up the melting of the ice. Right now, the Arctic ice cap acts like a giant mirror. All the sun's rays bounce off more than 90%. It keeps the Earth cooler. But as it melts, and the open ocean receives that sun's energy instead, more than 90% is absorbed. So there is a faster buildup of heat here at the North Pole, in the Arctic Ocean, and the Arctic generally, than anywhere else on the planet. The Earth's climate is like a big engine for redistributing heat from the equator to the poles. And it does that by means of ocean currents and wind currents. They tell us, the scientists do, that the Earth's climate is a nonlinear system, just a fancy way they have of saying that the changes are not all just gradual. Some of them come suddenly in big jumps. On a worldwide basis, the annual average temperature is about 58 degrees Fahrenheit. If we have an increase of 5 degrees, which is on the low end of the projections, look at how that translates globally. That means an increase of only 1 degree at the equator, but more than 12 degrees at the pole. And so all those wind and ocean current patterns that have formed since the last ice age and have been relatively stable, they're all up in the air, and they change. And one of the ones they're most worried about, where they've spent a lot of time studying the problem, is in the North Atlantic, where the Gulf Stream comes up and meets the cold winds coming off the Arctic over Greenland, and that evaporates the heat out of the Gulf Stream, and the steam is carried over to Western Europe by the prevailing winds and the Earth's rotation. But isn't it interesting that the whole ocean current system is all linked together in this loop? They call it the ocean conveyor. And the red are the warm surface currents. The Gulf Stream is the best known of them. But the blue represent the cold currents running in the opposite direction. And we don't see them at all because they run along the bottom of the ocean. Up in the North Atlantic, after that heat is pulled out, what's left behind is colder water and saltier water, because the salt doesn't go anywhere. And so that makes it denser and heavier. And so that cold, dense, heavy water sinks at the rate of 5 billion gallons per second. And then that pulls that current back south. At the end of the last ice age, as the last glacier was receding from North America, the ice melted and a giant pool of fresh water formed in North America. And the Great Lakes are the remnants of that huge lake. An ice dam on the eastern border formed, and one day it broke. And all that fresh water came rushing out, ripping open the St. Lawrence there, and it diluted the salty, dense, cold water, made it fresher and lighter, so it stopped sinking, and that pump shut off. And the heat transfer stopped. And Europe went back into an ice age for another 900 to 1,000 years. And the change from conditions like we have here today to an ice age took place in perhaps as little as 10 years' time. So that's a sudden jump. Now, of course, that's not going to happen again because the glaciers of North America are not there. And is there any other big chunk of ice anywhere near there? Oh, yeah.